Hi, and welcome to the first video in algebraic techniques and indices. In this video, we're going to talk about the language of algebra. By the end of this video, you should be able to describe the makeup of an algebraic expression and write your own from a worded sentence. So let's take a look. First of all, let's talk about some of the language behind algebra. We use the word pronumeral to describe a letter that can represent an unknown number, something that we're not sure of. Because it can constantly change this number, we call it a variable. We have some notation when it comes to variables. For example, when we have two variables next to each other, it means multiplication. So AB would mean A times B. And A over B would mean A divided by B. If we had two of the same variable being multiplied together, for instance, A times A, that would be written as A squared. Now you've got to remember that these variables that we're looking at, these pronumerals that we're looking at, represent numbers. So for instance, if A was 3 and B was 2, AB would mean 3 times 2. A over B would mean 3 divided by 2. And A times A would mean 3 times 3 or 3 squared. So these letters just represent numbers that we're not sure of right now. Now when we put these letters and numbers together, these pronumerals together, they make an expression. And that's a combination of numbers with pronumerals and mathematical operations. So here I've got two expressions. I've got 3x plus 4yz plus 9 and 3p over 2. Those are both expressions. Now within those expressions, they're made up of terms. That first expression has three terms, the 3x, the 4yz, and the 9. They're all terms. The second expression just has one term, 3p over 2. Coefficients are the numbers that are in front of our pronumerals. So the coefficient of x is 3, and the coefficient of yz is 4. Constant terms are numbers that are all by themselves. We call these variables x because x can literally be any number that we either want or have to work out. Whereas this constant term of 9 will always be 9 and can never change. Now, I referred to operations before in my example of what an expression was with mathematical operations. Operations are just plus, minus, times, and divide. And sometimes you can be given a worded sentence where we have to actually know what these words mean so we can use them in a sentence with a symbol. For example, when I say the sum of A and B, I mean A plus B. So I'm going to be adding those two numbers together. When I say the difference of A and B, I mean A take away B, because the word difference means take away. If I say the product of A and B, it means A times B. If I say the quotient of A and B, it means A divided by B. Or we could write it as a fraction as A over B. They both mean divided by. Finally, if I said the square of A, I would mean A to the power of 2, or A squared is a shortened way of writing that. Let's take a look at an example. Question A says to list the individual terms of 4a plus b minus 12c plus 5. And then in that same expression, we're going to state the coefficients of a, b, c, and d. In question C, we're asked to find out the constant term of that expression. And then for question D, we're asked to state the coefficient of b in a different expression. So I'd like you to pause the video and see what you can come up with for yourself. Okay, if you've paused the video and had a go, here are our solutions. For question A, the individual terms are 4a, b, minus 12c, and 5. There are 4 terms that make up that expression. For part B, the coefficient of A is 4, because 4 is the number in front of A. The coefficient of B is 1, because when we have no number in front of a letter, we have to assume that it's 1. It's not 0, because if it was 0b, it would mean 0 times b, and then it would go away because 0 times anything is nothing. The coefficient of C is not 12, it's minus 12, because the sign in front of the number the sign behind the number belongs to that number. And finally, the coefficient of D. Now there is no letter D in that expression, so you're probably thinking that I made a mistake. But when you don't see a variable there, you could say that the coefficient is 0, and that's why the coefficient of B isn't 0. So this is not really a question that you get asked very often, in fact, at all, except in this example. But I think it's important to note that coefficients of variables that aren't there are always going to be 0. You could say the coefficient of x is 0 and the coefficient of y is 0. Like I said, it doesn't come up very often, but it's important to know what happens when you have a coefficient of 0. Question C, what is the constant term? Now remember that the constant term is a number that is all by itself, a number that cannot change. So in this case, the constant term is 5. And finally for D, we're asked state the coefficient of B in that expression. Now the first term is 3a, so there's no coefficient of B there. The second term is 4ab, but that 4 belongs to the AB, not just the B, so we need to move on. The next term is 5b squared. Now b squared is not the same as b, so 5 is not the coefficient of b. And finally we look at the final term, which is minus 7b, and in this case the coefficient is minus 7. So minus 7 is the coefficient of b. Alright, let's take a look at another example. Example number 2. We're asked to write an expression for each of the following. We want to write an expression for the sum of 3 and k, the product of m and 7, 5 is added to 1/2 of k, and the sum of a and b is doubled. Now I'd like you to pause the video and come up with see what you can come up with. Question C and D are a little bit tricky, and you might have something similar to the actual answer at the end. Okay, if you pause the video and how to go for yourself, here's what we should have come up with. When I want to write the sum of 3 and k, sum means plus. This means that I could have written 3 plus k, or I could have written k plus 3. They both mean the same thing because it doesn't matter what order you plus things in. For B, it says the product of m and 7. Now the word product means times, so I could have had 7 times m, or I could have used the shortened version in algebra of just 7m. This is preferable, and you're going to be expected to write 7m. Now for C, it says 5 is added to 1/2 of k. So we need to work out how to write 1/2 of k and then add 5 to it. So we could have had a half with a k next to it, plus 5. Or if you know your algebra and you know the way to write things, you can also write it as k over 2, which means k divided by 2. And when you halve a number, you know you divide it by 2. So k over 2 plus 5 means that 5 is added to 1/2 of k. Now remember, k honestly is any number we want it to be. So if in this case, if k was 10, we would halve 10 and then add 5 to it. If k was 100, we would halve 100 and then we would add 5 to it. The reason why we use algebra is because this sentence that we've written means those two and every single other combination of what k could possibly be. Alright, let's look at D. The sum of a and b is doubled. Alright, so there's two ways of writing this. What's important is that a and b have to be added first, summed first. So a and b should most likely go inside a bracket, and then we're going to double it, which means we're going to times it by 2. So we want to write that a plus b is times by 2. If we didn't have the bracket in there, if it just said a plus b times 2, now our order of operations say that we have to multiply first. So we would have a plus 2b, or a plus b times 2, which would get done first, and we don't want that. The other way to write this, and this is using our shortened version for multiplication in algebra, is to have 2 outside of a plus b. And what this means is that we're going to take 2 and we're going to multiply it by a plus b. And because it's inside a bracket, we would do it first. And those are our solutions to example 2. So what should you write now? Well, there's a few screens I'd like you to copy down. I'd like you to pause and summarize the language of algebra. I'd like you to pause and summarize the expressions and what operations and what words mean the different operations. And then I'd like you to pause and summarize the 2 examples. And that's it. I hope now you understand how to describe the makeup of an algebraic expression using words like constant and term and operations, and that you can also write your own from a worded sentence. Good luck.